This is Unit 9, Lesson 10. It's our last lesson in this unit. In Lesson 9, we took a look at equations that we could graph and kind of visually look at where their solutions are. Here we're still looking for the same goal. We still want to know what the solution is to the system, except this time we're going to be solving algebraically. So quick recap of the two algebraic methods that we've done so far. We have seen substitution and elimination. The processes for each method works the exact same as they did in previous units and even in Algebra 1, except this time we're going to up the ante a little bit and we will be working with nonlinear equations as well as just linear equations. So first example we're going to look at is an example of the substitution method. So you can see here we have, this is a line and then this is a parabola. So same goal, we want to see where the line and the parabola intersect each other, except like I said, this time we're going to be solving it algebraically. So here's the way the substitution method works. You want to get one of the variables all by itself, which it already is with this one, and then you take that expression. So this says that y is equal to this expression right here, and you can sub it into the other equation when you see a y. Okay, so this says that whenever you see a y, you can replace it with this. So when we see a y here, we can replace it with that. So we have 4x plus y, but instead of a y, we're going to sub in x squared plus 5x minus 2 is equal to negative 20. So same top equation that we had right here, this y was replaced with this. So now it's all in terms of x. You see we have a quadratic equation. Whenever you have a quadratic equation, you want everything on one side. So x squared, the 4x, the 5x combine up to a 9x, and then this 20 we can add over to the left-hand side. So negative 2 plus 20 would be 18. We set that equal to 0. So this is a quadratic, meaning we start by factoring. We have an x times x. We are looking to multiply to 18 and add to 9, so that would be a positive 6 and a positive 3. We can solve those. When I set this equal to 0, I get a negative 6. And when I set this one equal to 0, I get a negative 3. Remember from our last lesson, our answers are always supposed to be ordered pairs, so make sure those get plugged in and you actually get a y value as well. You should not just have x's, you should always have x's and y's for these ones. So I'm going to sub it into my y equals equation. So when I sub in negative 6, this would be a 36 minus 30, so that's 6, and then minus 2 would leave me with a negative 8. And then when I sub this negative 3 in here, this would be a 9, and then minus 15 would be a negative 6, and then minus 2 would be a negative 8. Let me try this one again really quick. I'm sorry. This, I had the wrong sign. This should be a 36 minus 30, so it's a positive 6 minus 2. So this, my apologies, should be a positive 4. This one's the negative 8. All right, let's look at the elimination method. Elimination method is where you line things up, one variable on top of the other, and then you get your equations to eliminate. All right, so this, we have a y right on top of a y. We can get those to eliminate. So I am going to multiply the entire bottom equation by a negative 1. So negative here, here, here. That would make this a plus. So I've got everything all lined up. Y minus y would cancel out. X squared minus x squared would cancel out. So I have just a 0 on my left-hand side. 3x minus 5x would be a negative 2x, and 2 plus 4 would be 6. So now, just by making one of them negative, I eliminated a bunch of stuff. I'm working with a much simpler equation here. This is not a quadratic, it's linear. So linear means you want the variables on one side and the constants on the other. So move that 2x to the left. Divide both sides by 2, and I end up with x equals 3. Now I can take that x equals 3 and sub it into either one of the equations, really. It doesn't matter. We can take that 3 and let's say we sub it into just the top equation. So I have y equals, if I square the 3, I get 9, plus 3 times 3 is 9, plus 2. This ends up giving me 20. So again, make sure your answer is always given in the form of an ordered pair, and that would be our final answer. All right, so we've seen a quick recap of both the substitution and the elimination method. We're just going to do a handful of different examples here. So we've seen something like both number 1 and number 2 up above here. These directions will always be what you see either on a quiz or a test. It will be your choice what method you want to use. I'll kind of give you some advice through this video to give you more information as to when it would make more sense to choose a certain method, but when it comes down to it, the choice is yours. All right, so let's look at number 3. We haven't seen something quite like that one yet. So this one, see how the y is all by itself right here? I would probably choose the substitution method with this one because you can take this and sub it in right into that y right there. That would be one choice. Another choice would be if you're looking at how these y's are nicely lined up here on the left-hand side, the negative y and the positive y would cancel out. So that would actually be a great option as well. As I'm talking it out loud, I've just decided that the elimination method is actually my preferred choice here. But like I said, you could absolutely make it work either way. You're going to get the same answer either way. So the way it is set up right now, I'm just going to add the two left-hand sides together. So on the left, these y's will cancel out. The 3x combines with nothing else on the left-hand side, so it's just a 3x. On the right, if I combine up any like terms, the 7 combines with the 46, and then I still have the 2x squared, the positive 20x. Make sure when you're doing the elimination method and you're combining the two sides of each equation that you're only combining the like terms. Like you can't add the 7 and the 2x squared because they're not like terms. You can add the 7 and the 46. That'll give you 53. So this is a quadratic, which means I want everything on one side of the equation. I'm going to move the 3x over, so subtract 3x from both sides. Subtract 3x from the 20, and I get 17. And this is 53 right here. So I try to factor it. So this, I am going to try to divide out this 2, but I can't. This isn't divisible, this isn't divisible. So if I have to leave this here, I'm going to do the slide and divide method. So slide the 2 down to the end. Slide it and multiply by this, which I get 106. So I'm looking for values that will multiply to 106 and add to 17. So if I try to divide different things out, like 106 is divisible by 2. So 106 divided by 2 gives me 53. And 53, I don't believe, is divisible by anything. So it's either 2 and 53 or 1 and 106. Neither one of those is going to give me 17. So we could try a couple options, but I promise you we would fail, which means this does not factor. So if it cannot be factored, we are working with imaginary roots here. Okay, so you could try the quadratic formula if you can't factor it, but we would end up with imaginary roots. Let me show you really quick. So we do x equals negative b, which is the 17, plus or minus the square root of b squared, so 17 squared, minus 4 times a times c. Make sure you're using the original numbers, not the slide and divide numbers. And then all over 2a, so 2 times 1. So this, if I were to plug this in underneath the square root, plug it into my calculator, 17 squared minus 4 times 2 times 53. I end up with a negative 135. So I have a negative 135 underneath that square root. Those would be imaginary answers, so I would say no solution. Okay, I would have imaginary roots, which doesn't work for this stuff. All right, so next page, got a couple more picked out there. Let's look at number 4. So this one, I mentioned at the beginning that the method is your choice. Sometimes it's not really your choice because there aren't any common terms. This has an x squared, this doesn't. This has a y squared, this doesn't. Elimination could not possibly work here. And a lot of people get the idea that they want to square both sides or something like that, but that is likely more trouble than it's worth. All right, so this one, we kind of have to do the substitution method. So the y is by itself, so we can take this expression right here and plug it in for this y. So that'll look like this, x squared plus, and then in place of the y, I can put the x minus 6, though it is still squared, don't forget about that, equals 18. So remember what this means. It is not just squaring the x and squaring the 6. It means I have to write it out twice and FOIL it. So I have x squared plus, if I FOIL this out, x times x, outside minus 6x, inside minus 6x, and last would be a positive 36. equals 18. So this is a quadratic. I want to combine all my like terms. So I have a 2x squared. These combine up to a negative 12x. And then I can subtract the 18 over. So 36 minus 18 would be 18. So I just mentioned this with the last problem. If you're trying to factor, if this divides out, you do it. And this, because I have an equal sign, I have an equation, I can actually divide both sides by 2. So it seems like it just kind of disappears, but really I'm dividing the right-hand side by 2, and 0 divided by 2 is just 0. So divide everything by a 2. And then we solve it by factoring. So I have x times x. I need to multiply to 9, add to negative 6. So that would be minus 3 minus 3. So I come up with just this one answer here. I get x equals 3. And remember, your answer should be an ordered pair. So I'm going to take that 3 and I will plug it into either one of the equations. Makes the most sense to plug it into this one because it's smaller and it's easier. So I get y equals, plug in 3 minus 6, which gives us negative 3. So ordered pair here, 3, negative 3. Okay, next, let's look at number 6. All right, number 6, I would say, is probably a good substitution candidate. This is a y equals, this is a y equals. That means I can put this y equals right in place of this y equals. So I will have x squared plus 2x minus 7 is equal to 2x squared plus 3x minus 19. We have quadratics, which means we're going to get everything to one side and solve by factoring. So let's subtract all this stuff over to the right. So I'm going to move everything from the left. X squared, so 2x squared minus x squared is an x squared. 3x minus 2x is an x. And negative 19 plus 7 would be negative 12. So pretty straightforward factoring here. X squared would be x times x. And I'm multiplying to a negative 12, adding to a positive 1. So that would be 4 and negative 3. And then we solve for x, so set each piece equal to 0. When I subtract 4, I get negative 4, and then this piece I add 3 to get positive 3. So 2 different x values, but again, make sure that you are subbing those back in to get y values. So first ordered pair, negative 4, comma, I'd say this bottom one is easier. If I plug in negative 4, I get 16 minus 8 minus 7, and that would be 1. So there's one ordered pair. And then 3, if I sub that in, 3 squared is 9 plus 2 times 3 minus 7, and that ends up giving you 8. All right, let's do one final problem, number 8. This is an instance where you have a good setup for the elimination method because you have an x squared over an x squared, y squared over a y squared. So I would say that these are going to be the easiest to eliminate, the x squared and the 2x squared. So let's multiply this whole thing by a negative 2. You can make a great case for the substitution method here though as well. So I'm just showing you guys a little bit of everything. Okay, so whole top equation by a negative 2, and then just line the bottom equation right underneath. So here we go, line everything up. These will cancel. These combine up to a negative 7y squared equals, and then these combine up to a negative 28. Divide both sides by that negative 7. I get y squared equals 4. And then since this is just a square root, I just take the square root of both sides, or just a square. So take the square root of the left and right, and do not forget to include your plus or minus when you do that. So I have 2 different y answers. I'm going to sub those in to this right here. So I have x squared plus 2 times, and then whether I sub in the positive 2 and square it, or sub in the negative 2 and square it, I'm going to get 4 equals 17. So x squared, this is an 8. When I subtract 8, I get 9. So square rooting both sides, just like the other kind, I get x equals plus or minus 3. So this is actually technically 4 different combinations. All right, so this, my x value could be positive or negative 3, matching with either a positive or negative 2. So I could have positive 3 with positive 2, positive 3 with negative 2, negative 3 with positive 2, or negative 3 with negative 2. Every combination is possible there. And that's because this is an ellipse and a hyperbola. So picture you kind of have like an ellipse shape and then a hyperbola going like this. So it is going to intersect in 4 different symmetric places.